Hey guys, this week, chapter 8, we're going to be talking about tubing and how that really impacts us in the HVAC world. We use all different types of tubing: steel, PVC, copper. So this chapter is really going to talk about that. So I'm going to dive into that really quick, and then I'm going to show you guys the different things that I use and what's going to be really most common. So let's go ahead and just bear with me here. I'm going to do this slideshow thing really quick and off we go. So first thing when we start talking about the refrigeration lines and the copper is there's two different types. We have regular copper that we use for plumbing, water lines, that sort of thing. But when it comes to refrigeration, we have to use a thing called ACR. And what that is just it's designation stating that it's designed for air conditioning or refrigeration use, ACR. The copper is actually thicker. It's going to withstand higher pressures. Some of the pressures that we get into can reach an excess of 400, 500 psi. So we really need to ensure that we have a strong copper that's going to withhold that pressure. Plumbing, that comes in like a type K, type L, and then that basically just dictates how strong of copper pipe that you have based on the wall thickness. The thicker the wall, the more durable and stronger that pipe is. So you may or may not use some piping for plumbing purposes. It just really depends on the job that you're doing. So when we're talking about residential, we want to use at least a minimum of a type L. If we go to the big box stores, they're going to sell a type M, a type L. The type L is like a blue type of copper, and I'll show you the difference here in a second. But stay away from the M. It's the cheap stuff. Sure, it's copper, it comes in the right size, but unfortunately it just doesn't have that thickness that you need, and if you're going to get inspected, you're going to fail. So everything has to be a type L. So when we're talking about refrigeration lines, comes in copper, comes in stainless steel, comes in aluminum. Most of the time we're going to be dealing with copper, going from the condenser to the evaporator. Then we might actually run into a little bit of aluminum, the evaporator being made out of aluminum. Some of the older ones are a copper aluminum mix. And if we start dealing with ammonia or anything that has a really high pressure, I think ammonia is like 800 psi. You need something a little bit more durable. So we're going to be talking about stainless steel. So different types of ACR tubing. It's soft, hard drawn. Hard drawn is going to be like a big stick, 10-foot section. The soft is really going to come in more like a coil. You unroll it, and I'll show you that here in a second too. Stainless steel tubing, you use that really in like food processing applications. It resists corrosion, that sort of thing. Aluminum is just for evaporators. Not going to really touch or see too much of that. I did see somebody not long ago on a Facebook group. They went ahead, they had aluminum, they were trying to put that in, it exploded on them. If you can't, stay away from it. It's just too soft, too brittle. So wall thicknesses, K is a heavy wall, L is just a medium wall. Medium wall thickness is at minimum that we're going to use on any type of plumbing application. So if we're putting in a water heater, type L. All right, guys, so we got 2 sticks of copper here. The one on the bottom right here, this is 1/2 inch. It's a little bit smaller than the other guy. The other guy's 3/4 inch. Not sure if you can tell, but we got that red numbering, lettering, engraving on this thing. That's basically telling me that this is type M. And it says right there, 1/2 inch. If we look at this guy right here, the blue lettering, it's 3/4. It's upside down, but it is 3/4. The other thing too is when you go to the store, they got 2 different labels, so you can just tell really quick: red, blue. So blue, of course, upside down again, but we can see it's a type L right there, type M. M, garbage. So we can just get rid of that guy, only use the blue stuff. So now when we're talking about copper sizing, we're talking about either the OD or the ID. So the OD is the outside diameter, the ID is the inside diameter. When we're talking about ACR tubing, refrigeration tubing. It's the outside diameter that we're really concerned about. So if we're asking for a 7/8, that pipe is actually going to be 7/8 in size. Versus if I were to get a 7/8 copper pipe, what we'll have there is we'll actually have a 7/8 inside diameter, and then we're going to have the copper wall outside of that. So one isn't going to fit the other one. And that's done on purpose just to make sure that we're not mixing different copper pieces together. We can anneal copper. What that basically does is we apply heat to hard copper, makes it soft. We let it cool naturally. So we apply a torch, let it get nice cherry hot red. We let it cool down. Now all of a sudden it becomes softer, and we can bend it and work it and shape it like we need to. So ACR tubing, generally sold in rolls. It is difficult to put back into that coil. Some of the smaller stuff easier to work with than some of the bigger stuff, but you may be able to get away with it. So only unravel as much as you really need. So that pretty much covered copper. So now let's just go ahead and talk about PVC a little bit, or plastic pipe. PVC is the most common type that you're going to run into. We're going to use that for condensate drains, and we're going to go ahead and we're going to use that too for exhaust flues. So we get into high efficiency furnaces. The furnace does condense, so we can't use a metal type of flue anymore in there. So we have to use PVC or a plastic pipe. ABS, we can use that. That's really, I think, what the industry is going to start going to. ABS does handle heat a lot better than PVC. PVC starts to break down around 140, 150 degrees. They say it's good to about 170, but you know, things actually, I should say studies have been done to say that it does start to break down a little bit sooner than that. And our flue gases are going to be reaching 120, 130, 140 degrees sometimes. So we do have ABS, PVC, and CPVC. CPVC, we use that on hot, cold water lines, drains, and venting applications. So we could use CPVC if we wanted to. All right, guys. So you got a stick of 3/4 inch PVC right out for you. We can see right here, it's 3/4. Just like the copper, it's imprinted with the sizing on here. It's also got a Schedule 40 number on here, which basically means this is the thinner of the two types. We have a Schedule 40 and we have a Schedule 80. Schedule 40 is a little bit smaller, but for our applications, it's going to be perfectly fine. Schedule 80, you're going to be really talking about higher pressures where you really need a thicker wall on it. As we move on, it's going to tell us who the manufacturer is, any other info that they need. 480 psi is the limit on this pipe. Of course, it says PVC, and then at the end is just the manufacture date. The other thing that the book doesn't talk about, but you guys should know, is that we want to use a solid type of PVC. We don't want to use the other type, which I can't think of off the top of my head. Reason being, the other one is going to be more prone to breakdown, so we want to use a cellular core. So, a solid PVC. All right, so we just covered plastic pipes. Now let's go ahead and talk about steel pipes. Steel pipes, they're going to be used in the refrigeration system, like we talked about, stainless steel, ammonia applications, food processing, that sort of thing. If we're going to be talking about in residential applications, we're going to see it as gas lines, water lines. Predominantly, we're going to see a lot of it in the gas line side. That's how we run our systems and we feed the systems. We will run into galvanized pipe, and what that is, it's just a coated type of steel that has like a rust inhibitor on there, and it just allows it to withstand the corrosion over time. Unfortunately, galvanized does corrode, and you will run into that in certain older homes. Everything nowadays is being retrofitted to copper. Even if you do leave this area, you may get into plastic piping, which is called PEX. You may see that. You may see that even on the gas side. Just be aware that it is out there, but most of our stuff is going to be steel related. So let me go ahead and show you what a piece of steel looks like. So what we have here is just 1/2 inch steel. So we can call this black pipe. That's pretty much the most common name that a lot of people use here. So this thing is going to come with a sticker on there. It's a 1/2 inch by 30 inch. The reason this is already in a set length, unlike the other ones that come in 10-foot sections from the manufacturer, is that steel is very difficult to cut. So these things do come pre-threaded. So we have this cap right here, which I can't take off one-handed, but on the other side, this is what we'll see. We'll see these threads. They're called NPT, National Pipe Thread. And what that means is that we have a little bit of a taper. So from one side, as we start going deeper and deeper, we start getting bigger. So here, we're nice and small, and then as we get further away, bigger. And what that creates is a nice tight seal once we go into a fitting. Doesn't mean that these are waterproof by any means, but what it does mean is that it's going to help in sealing, whether it's a gas, water line, whatever. All right, so in front of us right now, we've got HVAC Tubing. This is a line set. When you go to the supply house, you're going to order a line set from them. And what that means is we're going to have 2 pipes in there. First one is this insulated one right here. This guy's a little beat up. That's why he's just in my little scrap pile. And then the second one is the smaller guy right there. Depending on the equipment size, is going to determine the size of the tubing. It could be a 7/8 for the larger. It could be a 3/4. And then on the smaller side, it's generally 3/8. Sometimes it may be a 5/16 if it's an older system, you know, whatever the case may be. If we get into ductless systems, we have a variety of tubing sizes, 3/8, 5/16, half, just really all depends on the application. So at the supply house, you're going to tell them, hey, I need a 25-foot line set, I need 35, 50, whatever the case may be. They're going to give you a box, and it's going to come pre-packaged, something like this. So that line set, the 7/8 here would come in a 50-foot length if that's what we order, the smaller guy, the 3/8, would also come in 50 feet. So both together are going to be 50 feet. If we need additional lines, we could just connect the 2, and so we can extend it. So for example, if we needed to go 70 feet, I'd order a 50-foot line set, and then I'd order a 25-foot line set, and I'd have 5 feet of scrap. The other piece right here is just a scrap piece of HVAC tubing, 7/8, and I'll show you guys a little bit more on how to cut that and how that really all works a little bit later. All right, so we went ahead and we talked about copper a little bit. Now let's talk about how to cut it. All right, first thing we're going to use is a thing called a tubing cutter. All right, this is a little bit of a bigger guy, and it's going to cut larger size copper tubing. It tells you on the side there 3/16 to 1 1/8 OD. So all we do with this guy is we're going to put the copper tubing right there in the middle, in between these 2 rollers and between this cutting blade. Try to do this one-handed. I'm going to tighten it up just a little bit so the blade starts to make contact, and all we do is just start to spin it. Once we start spinning it and make a revolution, we'll turn it a little bit, tighten it down a little bit more. Keep doing that until eventually we're going to cut this copper. You don't want to go too hard with it, otherwise you're going to misshape in the copper, flatten it out, and then you're going to be left with more of a problem than you are piece cut. So now we've got this cool jagged pointy thing on here. What we're going to do is we're going to ream out inside the copper tubing. See, there's like a little bit of a lip that's left here. If we take this guy and we spin in here, just do it a few times, start to see that that ridge is starting to disappear. What we're trying to do is we're trying to eliminate any type of restriction that we're going to get inside of there. So that's why we have this little reamer on the end. Now, if I have a smaller piece of copper, I could just use this little imp right here, and that's going to cut a little 1.125 3/16, very nice, or in little tight spots. But those are all my backups. The tool that I like, and I showed you guys this last week, is this guy right here. All you do, push it on, press the button, let it work for you. It's nice because it gets into like little tight spots and it'll make a perfect cut. Problem is right now I don't have a nice tight grip on here, so it's not going to cut it for me, but otherwise this will be done in no time. So that's how we cut copper. I know that the book says you can use a hacksaw. Don't use a hacksaw. You're never going to cut it straight. It's going to have ragged edges. It may not sweat properly, so forth. Always use a tubing cutter. All right, so what I got set up here now is a bender. All I did was I put in my 3/8 tubing right across the middle there, put everything on 3/8, and one-handedly I'm going to bend and put a nice 90-degree bend in my copper. All right, so just finished putting 2 bends in here. The one on the right is with the bender, and the one on the left is by hand. And you can actually see right there, there's like a little bit of a dimple in there, and that's just from me pushing too hard on it. I can't bend this thing with my hands and get it to as tight of a turn like that, and so I need to use a bend. If I were to use my hands and keep pressing over here, I'm going to kink it, and that's going to cause a restriction. I want to avoid that as much as possible, so we're going to use the bender. We can use springs, that sort of thing. There's a little manual bender that the book shows you. I personally like the ratcheting bender. Real nice, real easy to use. The bigger guy, 7/8, is a little bit more difficult, but you can still do it. Makes for a nice clean look when you're doing an install. All right, so I got my little flaring tool set up here. Basically, the way that this guy works, a little bit different than the one in the book. I've got my little copper coming up through here. All right, basically, I find the right size hole that corresponds to the size of the copper. Of course, this is 3/8. I have a little slider right here that I use as a depth gauge. Move that out of the way, bring this guy on, clamp them nice and tight here, and then all I do is spin this handle. All right, and that's what a finished flare looks like. So let me pull that out for you. And that's a finished flare. You can see how it's pressed outwards. And we do that with soft copper. We don't do that with hard annealed copper. Otherwise it's going to crack. When you do this, make sure that you use oil during the process just to help lubricate the metal components, so that way you limit any of the stress. So that's a flare fitting. We attach that via nut on the backside, and that goes and screws on. Makes a nice solid connection. You see these generally on mini split systems. So when we're done with that flare actually attaches right there. You see how it sort of has that 45-degree angle. The flare just sort of comes on there, sort of like that. The nut attaches on the backside and makes everything nice and secure. Same thing when you're putting the flare nuts on. Make sure you put oil on the backside of the nut, just to help with the friction portion. And when we're doing flare connections, we need to make sure that we torque them down to the manufacturer's specifications. If we don't torque them down, we will have a leak, and all of our work went for nothing. So now we have soldering and we have brazing. So what's the difference? Soldering, we're going to be dealing with low temperatures, anything under 840 degrees, and brazing is 840 degrees and above. So if we're doing plumbing and we're using regular, let's say a type L type of pipe, we're going to solder that. And the reason for that is we don't have to worry about the high pressures that refrigeration piping deals with, so that type of connection is perfectly fine. The problem is we cannot solder a HVAC connection, the refrigeration connection. The pressures get way too high and it will blow that solder apart. Now, there is a manufacturer out there that does sell a solder that's rated for refrigeration usage. I haven't used it. I've heard mixed results from it. Let's just be on the safe side. Let's just braze things and make sure that it's going to be a solid connection. I hate for you guys to get into the field initially thinking that soldering is okay on refrigeration lines, and all of a sudden you have a line blow up in your face. So let's go ahead, let's braze. The brazing equipment that we're going to need is an oxyacetylene torch. Basically, we can have pure oxygen and acetylene, or we can do air-acetylene. In class, when you guys start taking the brazing classes, you're probably going to be dealing with a lot of air-acetylene. It's just one tank, comes with a thing called a turbo torch, flame spits out, and you're ready to go. When you have an oxyacetylene system, you have to dial in your oxygen and your acetylene separately. When I showed you guys my little green tank there, that was oxygen. The acetylene comes in like a little silver tank, and those two were like in a little holder. And those are great because it really heats up the surface very hot very quickly. It keeps the heat from transferring too far forward down the pipe. So if I'm brazing right next to a valve, it's a critical component. If I were to heat that too long, I may start to melt the O-rings and the gaskets that are inside that valve, making a bigger mess. So with the oxyacetylene, I'm mitigating that. And the other thing that I will do is I will wrap that valve with a wet towel. The wet towel will start to absorb that heat before it starts to melt anything that's inside. When we're talking about regular sweating, this is what we have. We've got propane, MAP. We can use air acetylene. We can use oxypropylene. We can even use oxygen acetylene. Just be careful. We're not going to be heating it up to the temperatures that we need when we're brazing. So we're not going to be putting too much heat on there, I should say. If we were using the oxyacetylene, it gets very hot very fast, and if we're not careful, we will melt that copper. If we're going to use propane, the copper will get really red hot. Maybe if you're using a MAP gas, but you won't have to worry about melting the pipe. So this is the setup that I was talking about. Oxyacetylene, brazed very quickly. We have to make sure that our gases are dialed in properly and we're using the right torch tip. Make sure you guys wear lenses too. We want to make sure that your guys are safe. The other thing too is when you are brazing, soldering, that sort of thing, stay away from the fumes. Don't be overhead when you're doing it. Sometimes it's inevitable. If you have a respirator, wear a respirator, that sort of thing. But always try to mitigate the fume inhalation, just for your safety and well-being. Flashback arresters, basically it's like a little check valve. It's a one-way thing that's in your oxyacetylene systems, or any type of system for that matter of fact, or it should be there anyways. Basically what we're going to do is we're going to prevent that flame from going backwards into the system and causing that tank to explode. When we're talking about different flame types, we want a neutral flame. Neutral flame, we're going to be looking at that inner cone right there. We want to make sure that we don't have like a two-tone color like we do here, and we're looking at that main flame to be that bluish purplish tint. That's going to be a neutral flame. Proper lighting, we can use a little striker, we can use a lighter solder. There's different types of solder out there. Normally we're going to be using a 95.5. We're going to use also flux when we're going to be soldering. The reason for it is we want to keep impurities out of the soldering stream. what ends up happening is, as we start to apply heat to something, it starts to melt. Air, different contaminants in the air start to corrode that copper, and what ends up happening is we don't get a solid joint. We won't be able to get that solder to stick. So we basically, it's called like a primer. We prime that area, get it nice and ready and clean for that solder, and once we heat everything up, the area stays clean so that the solder has a good place to adhere to. The other thing we do with copper is we do clean it when we're soldering. We want to make sure that it's nice and shiny so that way it adheres to itself. If it's not, then we will never be able to get a good solid joint on there. The other issue that you may have is if you have water dripping. Water dripping in that pipe, you'll never be able to solder up that joint because that water is constantly cooling off that fitting of the pipe, whatever you're trying to sweat together. So they do sell a little tool that you can insert inside there to plug it up. I've heard the old bread trick. Never really had good luck with it. But what you do is you take some white bread, you stick it up inside the pipe, you get the bread to start soaking up the water, it swells up and technically creates like a little dam, so that way you can solder it, the thing up really quickly. Maybe, somebody's actually had it work for them. I tried it once. The other thing too is I don't know how I feel about having bread floating around in my system. So once it dissolves or whatever the case may be. So anyways, that's soldering. So yeah, we're talking about applying the flux, assemble the joint, apply the heat, and then what we're going to use, we're going to have a capillary action. We're basically going to apply heat to the fitting. So as we're applying heat to the fitting in the joint, that solder is basically going to suck in all of that material, and it's going to create a nice little seal for us. Another thing that I've seen people do, and the book doesn't tell you, is once you get that fitting all nice and hot, that solder will start to melt. Pull away the heat and just wrap that solder all the way around the joint. It'll still flow because there's still heat inside that pipe. Once you're done, grab a wet rag and just quickly clean up the area. All right, let's talk about brazing. So brazing is very similar to soldering. The only difference is that we're going to be using a lot higher of a heat, and we're also going to be using a different material. It's called brazing rod. It's generally going to be about 15% silver or higher. Just really depends on the application and your preference. The difference being is we don't have to use flux if you are brazing. The reason being, and the book says use flux, I've never had to. The temperature gets so hot that you're basically burning off any impurities that are coming in contact with that copper. The only thing that you have to be aware of is that depending on the type of system you're using, if it's an oxyacetylene, you may start to melt that copper and you may start developing holes if you're not careful. So always move that torch around. Don't let it sit in one spot. So here we are talking about the different fumes. Use a ventilated workspace. Do not breathe fumes. Keep fumes away from your eyes and skin. When we are brazing, we want to do a thing called purging. And basically what that's doing is we're trying to remove all of the contaminants inside the system. So what ends up happening is, if you've ever seen copper and we start to apply heat to it, it starts to discolor. Well, that discoloration is the carbon that's in the air, and it's creating this like little film on the surface of the copper. Now, what's happening on the outside is also happening on the inside. So we need to go ahead and we need to run nitrogen through our system while we're brazing. What that's going to do is going to carry any impurities that are in the system away from that joint, and it's keep it nice and clean. Otherwise, what's going to happen is that little black stuff is going to cake off, and what's going to end up happening is those little pieces are going to fall off and they're going to plug up the internals of your system. All right, so let's talk about swaging. Swaging is going to basically be the process of taking this one pipe and sticking them inside. Well, we're dealing with soft copper here, so this is very flexible. What I can do is I can take my hydraulic swaging tool, press it a few times here, and you'll start to see that copper expand. Release, and now my copper pipe will fit right inside. It's a little deformed, so it's not going to right now, but you get the point. The reason we want to do this versus using a coupling is we only have one braze joint right here. If I were to put a coupling on here, basically the coupling would slide over this pipe, so I'd have a joint right here, and then it would slide over this pipe, and I'd have a joint here. Well, that's just two areas that are prone to leaking. So if I can go ahead and I can swage my joint, stick this guy inside, and I only have one joint, less work for me, and it works perfectly. So that is swaging in a nutshell. And I just want to show you guys this also when it comes to swaging. We want to make sure that we are inserted quite a bit in there. So we want to be right where that area starts to dip down. We want a solid connection inside there, and the reason being is we don't want that pipe to fall out. We're really getting a nice meaty surface for a connection. Swaging tools, we can basically do the same thing like I showed you with the flaring, except we use a different type of end which basically flares it out. I showed you my hydraulic one. If you can get that, get the hydraulic swaging tool. It's a night and day difference. All right, so how do we connect the pipe? You know, we have steel pipe, we've got plastic pipe. Steel pipe, all we're gonna do is we're going to apply a thread sealant on the fittings. So that can be either a Teflon tape or it can be a pipe dope. Basically, it's like a little sticky substance. You want to use something that's going to be a yellow color for gas lines at a minimum. You may be able to use Blue Monster, which comes out like a blue color. That one's okay to use too. Stay away from the white one. White one's good for potable water, so that means just regular water lines. If you're going to be doing anything and everything, just use the yellow. Yellow is good for everything, or use the Blue Monster. That way you don't have to carry a bunch of different pipe dopes on there. Plus it's a little bit thicker, the yellow ones, that's why they use it for gas. If you do have a tricky system, like for example, you're dealing with water leakage and you tried the pipe dope or you tried the putty, or you just don't want to have any issues in the future, do both. Do the pipe thread first, or the tape, and then use the pipe dope on top of it. Generally, if you use both, you're going to be good to go. We don't use tape on gas fittings. Inspectors always want to see pipe dope, so just be aware of that. But if we are doing regular potable water fittings, the white PTFT-E Teflon tape is perfectly fine. Come in different thicknesses, different variations. They've got a gray one too that's a little bit thicker, so that's what we use for that. All right, so for plastic piping, we're going to use a primer and a cement combo. Generally, you can buy those as a little kit. You can buy them separately, whatever the case may be. We want to use a purple primer. There was a clear primer at one time, but everybody's gotten away from that because you couldn't tell if a pipe was primed or if it was just glued together. So basically, inspectors didn't like that, so purple is pretty much the way to go. I'll show you here an example of what that looks like. So this is my little scrap piece that I just had just to do some work with or whatever, but you can see that I applied some purple primer here first before I glued this together. And so all that is a little brush. You coat the pipe a few times. You go ahead, you do both the fitting and the piping. Then you take the cement. Once the primer dries, apply cement on both sides, put the fitting on, hold it for about 30 seconds, and you're good to go. It's practically instantaneous when it comes to PVC cement. All right, so how do we cut PVC? Simple. I've got these shears, real sharp blade. Basically, it's just a little ratcheting cutter. I come in, press down a few times. It's gonna just slice right through this, and I'm done. We can use a sawzall with a blade attachment on there. So if we're gonna get into larger stuff, this works really well. The PVC cutter works good up to about inch and a half, whatever it is. They come in different sizes. So nice little tool to have. All right, so this is my little just assortment of PVC fittings in here. Basically just gonna go over this with you real simple, real fast. So this is the primer. Different manufacturers out there, but we use this first. And then we have the PVC cement. I have a cleaner here. If you do spill some of that primer or you get it on something, use that really quick. It'll clean it up nice and neat for you. Otherwise, PVC primer does tend to stain things very quickly, so be careful with that. Very similar to steel fittings, you're going to have caps. Basically, we have a piece of pipe. We want to go ahead, we want to cap that pipe off so nothing comes out. That's what we use this for. We've got male fittings. So all these are just threads. I can screw this into something else, whether I'm going from plastic to plastic to metal, whatever the case may be. I can use this fitting. There's my coupling. PVC pipe is going to go on one side, PVC pipe goes on the other, and now all of a sudden I can join two pieces of PVC pipe. There's a little stopper inside there that's going to stop the pipe from going in too deep. I've got some male caps. This is the Teflon tape that I was talking about. Generally, when you're going to be doing Teflon, I'd make about 4 wraps on the threads themselves, just to really give myself a nice little tight, secure connection. We call these little 90-degree elbows. Plastic tees. They come in different variations, sizes, but overall, this is exactly what you get. You may be able to get like a 3/4 on one side, a 3/4 here, and a 1/2 inch here. So you don't have to use an adapter. I've got a little female adapter here. So if I'm going male to female or whatever the case may be, that's what that's for. And 45s. Yeah, that's the assortment of PVC. Let me show you metal. So here we are. Here's my black fittings, steel fittings. Got a little adapter here, a reducer. So we're going to go from 3/4 to 1/2 inch. Sometimes that's the case. You've got a 3/4 inch main gas line running. I only need a 1/2 inch supply for the furnace. That's what that's for. Same thing. We got some caps here. Got some plugs, elbows, T's. We have 45s and couplings. Now, the unique thing about these guys is anything that has a female on one side and a male on the other, this is called a street fitting. All right. What that basically means is that this allows me to get into really tight little spaces without having to use a little nipple. So if I have just a piece of steel piping, just like this, all the way up to 5 inches, 6 inches, they call it a nipple. Sometimes it's a little tight fitting. I need to be able to get in there. I use these street elbows. So try to avoid them. Some people say that they do have a potential to leak much easier than a regular fitting in a nipple. I've never had that problem, but just be careful. Sometimes coating is different depending on where you're at. And then I just have a little shut-off valve. So and that's pretty much what you'll see as far as black fittings go for the most part. Different variations, different sizes, going from one size to a smaller or larger and that sort of thing, but this covers most bases. All right, so that pretty much covers all of Chapter 8 in a nutshell. Really trying to do the best I can with the limited resources that we have. Hopefully this helps you guys out. If you do have any questions, any issues, feel free to reach out to me. I will be available during the class time, so send me a message via the email, and we'll go from there. So talk to you guys again next week.